Okay, so what you want to do on this, what kind of function is this? Guys, listen. What kind of function is this? Where's the x variable? It's up here in the exponent, right? So we call this an exponential function. All you need to do is go to your calculator, all right, and then type it in, 2, whoops. Okay, go 2, and then get your exponent as a variable. Make sure you cursor out, okay, and then minus 2. And then graph it. Okay. Now, a couple things that you can do. You can graph this. The other thing that you can do is, if you remember your translations, okay, write this down. This is the translation where a, x minus h, and then plus k. Right? Okay, the h gave it a what? Left or right. And then the k gave it a up or down. You guys remember that? Okay, so if I'm looking at this, is it going to have a horizontal shift? Left or right? No. Okay, is it going to have a shift up or down?
Yes.
How much? Going to go down 2, so that's going to be my k. Everybody clear on that? Now, some things that you can, if you know that, and you know the translations, you can answer these questions. For example, if I'm moving down, what's the asymptote if there's nothing out there? It's always going to be what? Y equals 0. Okay, that's standard. That's the parent graph. Well, if I'm going up or down and not left or right, does my horizontal asymptote change? I'm going up or down, right? So it's going to change to a y equals -2. That's what that number is. Because what did my graph do? Shifted down, right? Okay, so that's your answer for that. How do I find the x-intercept? Just go to your calculator, right? Yeah. So where it crosses, so which coordinate has to be 0? If I'm looking at this, and I go to second table, okay, if I go to the second table, the x-intercept, which coordinate has to be 0? The y. So if I'm looking at this, all I got to do is go to this y column, scroll down, find 0, which is right there. Okay, so my x-intercept is going to be 1, 0. How do I find the y-intercept? What am I looking for? Yeah. So if you look right above it, the x is 0. So that makes y -1. So it's going to be 0, -1. Where it's crossing the y-axis, right? Okay. Does it represent growth or decay? It's going up, so it's got to represent growth. Now remember that for later, and I'll explain why here in a second. If I'm talking about domain, what do we say my domain is on all exponential graphs? It's all real numbers. Always. So you need to identify what type of function it is, right? All exponential functions, that's what I've got right here. Since x is in the exponent, it's an exponential function. So this will be true for every graph that you graph. Okay? On the range, okay, the first thing I need to figure out is it growth, and if it is, then my sign is going to be what? Greater than. Right? Because it's doing what?
Growing.
It's growing. Okay? Then I need to determine what my horizontal asymptote is. If I know that, then all my y values have to be greater than -2. Or something. Yes?
Yeah.
Okay. Everybody good with that? Okay, now, you don't have the graph on yours. Okay, you don't necessarily need it. The only reason I have it on there is because I just wanted to show it to you visually. Okay, so you can see it. Is everybody clear on that? Okay. Other than that, all right, this is 7.3 stuff. Okay, we want to write that down. This is 7-3 that we just got through doing. The first thing I need to identify, guys listening? First thing I need to identify is what my base is. Lily, are you with us? Find the base. Okay, what's the base here? 2. Is it greater than 1 or is it in between 0 and 1? Okay, so write that over here on the side. B is greater than 1, 2 is greater than 1. And we said that my B is equal to 2. Okay. So, if I know, all I need to know now is this part right here, I'm going to graph. And that becomes my parent graph. You guys remember the points that we used?
0, 1.
No, backwards.
1
1, 0, that's standard. Now, what is that? That's also going to be the what? X-intercept. Right? Okay, then the other point was B, 1, and then 1 over B, and -1. Is everybody clear on that? Okay, what am I graphing first? The parent graph, right? I'm graphing the parent graph. So the reason why we said that we want to know that B equals 2 is because now I can change these points. Instead of writing B, what can I put? 2 and 1. And then 1 over 2 and -1. Plot those points. Okay, just like so. Okay. Do I need to connect those dots? No, because what am I fixing to do? I'm fixing to translate them, right? I'm fixing to move them. Okay? How much are we moving these dots by?
You're moving to the left 3.
Very good. So I got a +3 inside with the X. So we said that's an H, right? If it's an H, it goes in the opposite direction of the number. Okay? Is there anything out here to the side?
No.
Okay, so K equals what?
0.
And if you want to, H equals -3. So each one of these dots are going to move.
3 left.
Okay, so 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, now, how do I find the vertical asymptote? Well, it's basically what? Isn't it basically my h? Isn't it? Okay, so my vertical asymptote is going to be x equals -3. Did my x-intercept move? Okay, it was what? 1 and 0, but we translated it, which means it moved how many units? 3, right? Is it -3 or is it a different number? It's actually -2, right? It's right here. Oops. -2 and 0. That's that answer. Now I could do this. If I know that my x-intercept is 1 and I have to move 3 units to the left, what can I do? I can just add those two, right? Which gives me -2. Any questions? You guys good on that? Pretty easy. Just follow my squiggly, right? Also, too, I want you to notice over there on the far right, you guys look it over there. In blue right there, you have growth and decay, okay? And then down here in the box, you have y equals AB to the x power, and there's your translations, and then it's the same thing for the logs. And that 1, 2, 3 right there, those log properties. Now a little bit it's got erased, so I'm gonna have to. If you need that for reference, use that. Okay, because you won't be able to use your composition book, right? So you can go back and look at that. How do I do this?
You just do the arrow in the circle.
What's my base?
8.
8. So I'm gonna start at 8. I go through the 2 back to the 64. So 8 squared basically equals 64. Pretty simple, right? Okay. So you're going to exponential form, gotta look like an exponent. Here I'm going to logarithmic form. So what do I need to start with? Log. My base is going to be 19. That's where I start. The next number will be 1. And then the next number would be equals 0. Pretty simple, right? Okay, now, next. Do what?
We need to have a lot of those on the desk.
I don't think there'll be only a couple.
Why?
Because there's other things you gotta talk
Most
about.
important thing, man.
Okay,
No, it's not.
now, let's look at this one real quick. This is a word problem that you can do on your calculator, okay? What kind of function is this? Exponential, good. Okay, how do I know? Because the x is where? It's in the exponent. It's the power, right? Okay, so here's what you need to understand. Y is the population, okay? The most important thing is that x is what? Number of years since 2005. Okay, so now, if I were to do an input-output table, that's Y1, which you can do on your calculator, right? Okay, here's what you need to understand. 2005 would be what? Well, it's since 2005, so 2005 would be what? 0. That would be my starting point. Correct? Okay. So, what would 1 be?
2006.
2 would be,
2008.
so on and so forth. Is everybody clear on that? Okay, so when I input this in my calculator, That's what you're gonna be looking for. Is everybody clear? What would, if 2005, what would 0 be? What was my starting population? 40,000. So my Y would be 40,000. You see what I'm getting at? Okay, now, this is the rate that it's increasing. That's just a rate. All right, we're going to let the calculator do that for me. Is everybody clear? All right. So we want to approximate the population, which means approximate means I'm going to do what? Round up or down. Oh. I'm going to round up or down. Okay. In 2016. So how many years is that going to be after 2005? How can I find it real quick? Can I not just subtract them? So I need to find 11 on my calculator. Hello, you guys with me?
Yep.
Yeah, it's hard to tell because it's like everything's fixed it up. All right, so come over here. Plug it into your calculator. Make sure you plug it in so you know you're doing it right. I'm going to start with 40,000. Go parentheses, and then it's 1.035? 35, and then I need an exponent in my variable, parenthesis.
No graph doesn't pop up.
What's wrong? Hello? What's wrong? Wake up. What's wrong?
No graph.
You sure?
There's no graph on the thing.
Why is it not showing up though? What's my window? I'm only going to 10. Well, what's my Y start at? 40,000. Right? So what's going to happen is you're not going to see a graph, but watch this. If I go second, you guys listening? Because this is an easy problem you shouldn't get wrong. If I go second table, notice what pops up. Okay, so now if you scroll down, what did I tell you to look for? What year is this? If you notice, there's a 40,000. That was my starting population, right? Okay, so all I got to do is scroll down. I know 2016 is how many years? It's 11 years. What's my population?
58,399.
Right, but approximately it's going to be what?
58,400.
Yeah, I would just say 58,000. Okay? Yeah, make sure, check your answers, right? Okay, see which one they offer. Does everybody see how I'm doing that? I mean, that's like super easy. Okay, now, next question. Approximately how many years after 2005 will it take for the population to double if it started at 40,000? What's double?
80,000.
80,000. So now, which column do I need to focus on here? Okay, find the Y. Focus on the Y column. There's 58. I'm just going to keep scrolling down until I get to what? So how many years?
21.
21 years. It's going to take to double. No,
Yeah. Oh, why not?
because this hadn't actually doubled. You got 500 people away from it, right? Okay, so it doubled from here to here. So you got to put 21. Does that make sense? Okay. All right. Okay, 41. These are super, super easy. First thing you want to check is what? What have I always told you when you're dealing with lots? What do you got to check?
Base.
The base. Okay? Now, if you notice, you got a log on the left side. Are you adding or subtracting it to any other logs? Okay? What about on the other side? You got any other logs over there? Okay, so if the bases are the same, which they are in this case, all I have to do is take this and this right here and set them equal to each other. And then solve for what? Solve for K. Hope you're writing this down, Logan. You're not going to get credit for it if you don't have it written down. Everybody good so far? Okay. This 42, write this down. Properties of adding and subtracting logarithms. Okay, so what I want to do is pretend like that's X, and I'm going to pretend like that's Y. Are the bases the same?
Yeah.
The bases are the same. So I can apply a property here. When you have subtraction, you're subtracting, you're going to rewrite this as log of 8. Stay with me, write it down. Jane, are you watching?
Yep.
Log of 8, and then I'm going to take the 2x and put it over 2 and write it as a fraction. Okay, so the rule is log of bx minus log of by is actually going to simplify to log of b x over y. And that's subtraction. If it's addition, what do you suppose you're going to do? You said divide, you would multiply. Okay, so you may want to write that down here. Log of b to the x plus log of b to the y. And I'm going to go log of b x times y. Now, you have to make sure, okay, that what is the same? The b, or the base, the log, okay? Got to make sure that that's the same. Okay, so when it's addition, we multiply. When it's subtraction, we do what? We divide. Okay. Here's what I'm going to do. I'm going to rewrite this, which I did. This equals what? I'm going to bring that back in now. Hello, you guys with me?
Yes.
Pay attention. Okay, now I'm going to use my logarithmic rule property. And I'm going to bring my squiggly line back in. My base is what?
8.
So I'm going to rewrite this as 8 squared exponentially equals 2x divided by 2. Okay? Exactly. 8 squared is 64. How do I get x by itself? I gotta multiply by 2, then divide by 2, x equals 64. Now I could have, I think Riley is saying this, I could have multiplied this by what? 2 over 2?
Oh no, I was just saying the bottom number, if you multiply it by 2, so you get the 2x and 12.
If I multiply it by its reciprocal, 2 over 2, so basically I'm left with x, shorter version. Okay, and then right here, put that over 1. 2 will go into itself 1, so it'll be that, it'll be what, 32? You essentially get the same thing. 2 over 2 is what, anyway?
1.
It's 1, so 1 times 64 would have been 64 anyway. Right? Okay. If you're really good with your Algebra 1 skills, you know, it'll save you some time to go quick like that. Alright? If not, just do it like we just did there. Any questions? Hopefully I've helped you. Again, bonuses right here.
Can we turn this in?
I would hang on to it so you can study it. Bonus?
Yeah.
And now, again, remember, all I've done on the bonus is it looks just like the review that we just worked. Okay, so again, your actual exam that you're going to take, is it going to look like this?
No.
In format, it will. But it's just going to have different numbers
And multiple choice answers, right?
and multiple choice. Okay? So you need to be prepared for that. Anybody else?
Got it.
Yes or no? Or you don't know? You got two? Somebody may have already grabbed one. Right, over here. Going. Anybody else?
Today's the 27th?
Yeah, I think so.
No, today's the 28th.
Last 10 February, right? You want one?
Yeah. Or then no, I got one, but can I can
Yes, you can. I was fixing to just ask you that. I think that's yours too, isn't it?
Okay.
Lily, come here for a second. Do you want to finish that?
I thought you said I couldn't.
I don't know, let you finish it. I'm giving you an opportunity. Do you want to do it or not?
Yeah, I do.
Okay. Does it matter if I said no or not? At this point, does it matter?
Yeah.
Here's that. You see what I'm saying?
So it's just,
It doesn't matter what I said before. I'm giving you the opportunity now to do it. Okay?
okay.
I would probably take advantage of it. This is the kind of guy I am. Go ahead and take everything off your desk, all right? You need to
That's this month.
finish that?
What?
Are you finished?
What? This?
Yeah.
Yeah, no, I finished it.
Okay, good. Perfect.
Not many of the restroom.
Yeah, all right. Hey, Hannah. What's your plan on that?
Do you want me to take mine
Are you ready for it? Okay. Let's grab a calculator and come over here. Let's just take it over there. Just leave your phone. Logan, get to work, dude. Alright.